All right. If you guys remember the other day, one of the experiments I had you guys do was the pop test, correct?
Yes.
Yes. And what were we doing with the pop test? We were burning what and what?
Oxygen.
Oxygen gas with hydrogen gas. And what did that form? Water. So, yeah.
Oh yeah, and the flask, right?
In the flask. It made like little condensation on the side.
Yes.
So this is also a redox reaction. But the challenge you're going to face here versus the other ones is we can't use the charges to figure out what's going on. So what we're going to need to use instead is something called oxidation numbers, because oxidation numbers are a way for us to see oxidation and reduction without having to rely on the charges. So some things to keep in mind is that there's a list of oxidation number rules, and we can again use this in our justification for this part here. So first thing we got to keep in mind is there's a whole list of rules here. Some elements are specifically named, others are not, and so we have to use some oxidation math to figure it out. I can see that oxygen is named, and it says that oxygen in compounds has an oxidation number of -2. Actually, let me backtrack. It says, number 1, in the elemental form, atoms have an oxidation number of 0. So anything that's in its pure form, oxidation number is 0. So when I look, I have hydrogen. Hydrogen's by itself, that's in its elemental form, that is 0. Oxygen, also in its elemental form, so that is 0. So that's something to keep in mind when we're looking at this. Next thing to think about then is we have some rules when it comes to hydrogen and oxygen that we can use. There's also this one here. So everything we've done previously, you can still apply oxidation numbers to. Elements that are monoatomic ions have the same number as their charge. So this one would have an oxidation number of 0. This would have an oxidation number of +3. This one would have an oxidation number of 0. This would have an oxidation number of -1. Are we okay with that so far? Just applying some rules. Other things to keep in mind is that the positive and the negative signs, when we're talking about oxidation numbers, go before the number. When we're talking about a charge, it goes after. So just watch out for that. All right. So that's the first 2 rules. Second rule is I have oxygen. Oh my goodness, I'm so dumb sometimes. Forgot I turned this off. Hopefully you guys are still following along. It should be starting up. It is recorded, so that's good news. Okay. If you guys look at rule number 3 for the SciPad page, it says oxidation in compounds as a number of -2. So any sort of compound that I have it in, it's going to have -2 as its oxidation number. With the exception of peroxide, in that case, it'll be -1 instead of -2. So no, come up. So this is oxygen in a compound, so its oxidation number would be -2. We good? All right. Next one, it says hydrogen in compounds has an oxidation number +1, except if it's in a metal hydride, which in that case it's -1. So there's some exceptions to the rule, but in this case, for the most part, we're dealing with +1. In this case, we're talking about water, so hydrogen is a +1. So that's how I'm pulling these numbers. You can also see some other rules here, and this is what I call oxidation number math. If it's a polyatomic ion, the sum of all the atoms adds up to the charge. And then with the molecules sum up to 0. So we see a molecule here. This hydrogen, you see how there's 2 of them. So really that's +2 plus -2, that equals 0. Which matches this bit here, oxidation numbers in a molecule sum to 0, which that proves. So if you're in a situation when you have something and you can't figure out its oxidation number, you can use oxidation math and a little bit of algebra to figure out what it is. Some things to keep in mind is that this oxidation number, again, is referring to per hydrogen, not total. All right, but from that information, I can figure out oxidation and reduction. I see here that hydrogen's oxidation number has gone from 0 to +1. Increase in oxidation number is oxidation. So I've identified this one as that. And then in the other case, oxygen's gone from 0 to -2. So that's a decrease in oxidation number. So decrease in oxidation number, that is reduction. So you can still figure out oxidation and reduction from that information there. So just another method to find the same information. Again, you can fill out the sheet like we normally do, talk about what oxidation means, what reduction means. You now have an additional definition, which is the increase or decrease in oxidation number. So you can write that down as your definition as well. So you write down oxidation is the loss of electrons or an increase in oxidation number. Reduction is gain of electrons or decrease in oxidation number. Both of those will work as definitions. And then merit, you're just linking your observations there. On the back side, we talked about gain and loss of electrons and the half equations. These half equations will be a little bit more complicated, I believe. Yes, it will. So you will need to do those next bit of the extension, which is, I lie. It was what I was going to plan to cover on Monday. I won't give you a question like this on the assessment because it does require you to balance the hydrogens or use the complicated system. So this bit here is what we're going to look at on Monday for those that want to aim for top scholar. But I won't be giving you something like this on the assessment. Just want to point out for this one, because it does use, like I said, oxidation numbers. When you're doing your justifications then, sorry about that. So, just as a note, the hydrogen in H2 has an oxidation number of 0. In H2O, hydrogen has an oxidation number of positive 2. Increase of oxidation number, therefore, it is oxidation. So just another way to explain it. And then this one, you do the exact same thing. The oxygen in H2 has an oxidation number of 0. In water, oxygen has an oxidation number of negative 2. That should be positive 1, sorry. That should be a 1, 2. Increases oxidation number by whatever. All right, so that's just a little bit. You guys obviously can have a little bit more practice on that, but tomorrow I do want to give you guys your first attempt. There are plenty of templates if you guys want to take some more.